All right, in this example, we're going to be looking at an application of the factor theorem. Okay, so we are given an expression for the volume of a rectangular prism. Now remember, the volume of a prism is length times width times height. So we know we have three items being multiplied by one another. This says determine an expression for the missing dimension. So what are we given? We're given that the volume of some prism is 3x to the third minus 14x squared minus 7x plus 10. And the two dimensions we know, remember we had a length, a width, and a height. The two dimensions we know are x minus 5 and x plus 1. And they want to know what would the other one have to be. There are a couple ways we can go about this, but since we're studying the factor theorem right now, let's use that. So the factor theorem says that if you have a factor of a polynomial, when you divide it in, you will get a remainder of 0. And we can use an extension of that to break down polynomials when we know what their factors are. Okay, so we start this by setting up our synthetic division. We know that if these are factors, we should get a remainder of 0 at the end. The other thing we know is this polynomial we're left with, we can continue dividing to make it smaller and smaller and find more factors. So I'll show you an example. We need to double check our polynomial before we use synthetic division. We have third power, squared, first power, constant. So everything is there and we're in order from largest degree to smallest. We write down our coefficients. So we had a 3, a negative 14, a negative 7, and a 10. Now let's divide first by this x minus 5. Again, when you're using synthetic division, you wouldn't divide it by negative 5. We divide by the solution when we set it equal to 0. Okay, so we are dividing by 5 out here. You drop the first number straight down, so we get a 3, and then 5 times 3 is 15. And then we add, negative 14 plus 15 is a positive 1. Multiply, 5 times 1 is 5, and then we add, negative 7 plus 5 is negative 2. And we multiply 5 times negative 2 is negative 10, and like should happen, we get 0. Okay, if it's a factor, you should get a remainder of 0 here. What that's done for us is told us also what the polynomial would be left if we divide by x minus 5. Each time you do synthetic division, it drops your polynomial by 1 degree. Okay, we had x to the third here, but since we've taken an x minus 5 out, it would drop to an x squared. And so what you can do is write the remaining polynomial using these coefficients. Again, you drop 1 degree, so it's going to be an x squared, so it would be 3x squared. I'm pulling the numbers from right here. A positive 1, so plus 1x, we just go down, and then a negative 2, so minus 2, and we don't have x's, right? See, it goes x squared, x to the first power, and a constant. So what we've determined right now is that this polynomial can be factored as x minus 5 times 3x squared plus 1x minus 2. Okay, so that's what we're doing here. We're factoring out polynomials, making it smaller as we go. Well, we know that we had another factor as well, x plus 1. Okay, so rather than start over again with the x plus 1, we're going to use what came out the bottom here, this 3x squared plus 1x minus 2. We're going to divide by x plus 1. So again, what would we be dividing by out here? If we set that equal to 0 and solve, we get x is negative 1. So we're dividing by a negative 1. Drop the first number straight down, and then we multiply. Negative 1 times 3 is negative 3. We add, 1 minus 3 is negative 2. Multiply negative 1 times negative 2 is positive 2, and like we expected, these two add to be 0, a remainder of 0. Okay, so what does that tell us now? Well, we divided by an x minus 5. Okay, then when we divided the remaining portion by x plus 1, our solution was, now look, we started with an x to the third, dividing this one dropped it to x squared. So if we divide again, we're dropping to x to the first power. It would be 3 x to the first power minus 2. That is our remaining factor. Okay, so notice we've factored as far as we can go because they're all to the first power. So what were the dimensions of our rectangular prism? Well, it was x minus 5, x plus 1, and here is the one that was missing, the 3x minus 2. Okay, that can be a little crazy the first time you see it, so we're going to do one more. Again, if you want to pause it and then try on your own and then check your answer, that's great. If you want to follow along, that is great too. So we're given the same type of situation. Okay, we are given the volume of a rectangular prism and 2 of the dimensions, like the length and the width, but not the height. And we're asked to find the one that's missing. So we're going to use synthetic division to break this down. You could also use long division if you like that, but if you get the hang of synthetic, it seems to go faster. Double check your polynomial. We have third power, second power, first power, constant. It's in the correct order and nothing is missing. So we write down our coefficients. So we have a 4, and then an 11, negative 17, and negative 42. Let's start with our x plus 3. Again, I mean, I'm sure you've shortcutted this already. You know that. You just change the sign. But we will be dividing by negative 3. Drop the 4 straight down. Negative 3 times 4, negative 12. And we add. 11 minus 12 is negative 1. Negative 3 times negative 1, positive 3. We add negative 17 plus 3, negative 14. And we multiply negative 3 times negative 14, just like we expected. It's a positive 42 and gives us 0 here. It should happen that way or you've made an error. If this is a factor, you should get a remainder of 0. Okay, let's drop another step. Okay, so again, remember, notice that tells us that if we divide by x plus 3, the remaining polynomial, we drop a degree, so it would be 4x squared minus 1x minus 14. And we're going to divide that by our other factor that was known, which is x minus 2. If you're dividing by x minus 2, it means we're dividing by a 2. Drop the first number straight down and then multiply. 2 times 4 is 8. Negative 1 plus 8 is 7. 2 times 7 is 14. Negative 14 plus 14 is 0. Okay, so what do we have remaining now? Well, we divided by x plus 3, and then we divided that by x minus 2. For some reason I wanted to put something else. And what was left? Well, we went from cubed to squared, and this would be to the first power. This would be 4x plus 7. So our remaining dimension is 4x plus 7.